Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate
Before we can start talking about our new function family, we need to understand a particular concept. We need to understand what our inverse is. So when you invert something. So I have two functions for you, so let's talk real quickly what this is. So I have some function called f of x, and here's a table of values generated from my function f of x. Now this is the inverse of f. Notation's a little interesting. So the little -1 here is not an exponent, it's a symbol that used to represent that this function is the inverse of the function f. So they both have the same label f, however the little -1 signifies that it's the inverse of the function f. Now, what's the relationship between them? Well, first, let's go ahead and graph these sets of points. Here's my graph of f of x. Now, how are we going to graph the inverse? Well, here's what's really cool about the inverse. The relationship between the inverse and function is that the inverse switches the domain and range. In other words, all the inputs on the function become the outputs on the inverse. All the outputs on the function become the inputs on the inverse. Essentially, we take every single coordinate or ordered pair and we switch them. Here's what I mean. Do you see all these inputs on f? They become outputs on f's inverse. Do you see all of these outputs on f? They become the inputs on f's inverse. Now let's graph these. So this is what's really cool about any function and its inverse. Let's look at this point, for example. This point is the ordered pair 2, 4 on the function. But if I switch 4 and 2, it becomes the ordered pair 4, 2 on the inverse. That's it. That's how simple that is. Graphically, if you look at these two pictures, you're going to notice something. They are reflections of each other. And they reflect over the line y equals x, also known as the identity function. So, let's recap what we have here. The domain, or inputs, or x values on my original function will turn into the range, or outputs, or y values on my inverse. The range, or outputs, or y values will become the domain on my inverse. So, just to recap, when you take an ordered pair on the function, just switch them, they become the ordered pair on its inverse.